four types of chemical weathering that we need to talk about. And I'm just going to introduce chemical weathering to you and give you the concepts. Chemical weathering requires some knowledge of chemistry, so I'm not going to get really into the chemistry. Rather, I want you to understand what gets produced out of this chemical weathering condition and how it appears and just the general foundation and basics behind them. So, chemical weathering is all about decaying the rock and minerals. And with that, that happens two ways, either through water or either through plants' organic acids. So we're going to add an acid to rocks and basically cause the mineral to dissolve in one way or another, or to decay and decompose in one way or another. With water, there are three agents of chemical conditions that are produced, and I'm sure you're familiar with all of them. That's oxidation, think rust; carbonization, so think about soda that you use for baking. So baking soda is a rock. Baking soda is a rock, and you add a little bit of vinegar to it, and you watch it carbonize, right? And then solution is to pull that mineral out and then create a solution out of it. So think of soda as a solution. All of that, those like a sugar dissolved in water to create soda is a solution. And then plants give off acids, and enough acid interacting with a rock and the right rock over time will create decay of the rock. So the two types of chemical weathering on this slide are spheroidal weathering and hydrolysis. So what's happening with spheroidal weathering is that on the surface of the rock, with rain events and flood events, what's going to happen is the rock itself starts to dissolve. The rock is being dissolved by the water. And as it dissolves, then the water moves on, evaporates. That agent that was dissolved produces like a crust on the rock, a cementing compound, and it starts to encase in rounded shapes, little balls, that out of this stuff that was leached out, that was pulled out of the material that was dissolved by the rock. Hydrolysis, on the other hand, is what we often see when we see buildings start to lose their nice crisp shape. So I've got a figure of an individual who was carved here, a statue. And we can see that the face over time has lost its definition. That's hydrolysis. So what's happening here is the water is interacting with this particular rock, and it's producing a new mineral between the hydrogen and the oxygen bonds of the water and the minerals that were originally in this rock. And what it ends up doing is it's not as strong as the original mineral composition, and it's able to then dissolve with wind or with frost wedging, and then it just sort of flakes right off. So that's what's happening with hydrolysis. The last two, are oxidation and rocks oxidate. You and I know oxidation with iron rusting. All metals for which come from rocks go through an oxidation process, and it's very much just like the hydrolysis that we talked about. We're creating a crust on the outside of the original rock structure, and it's weak, and it then is able to break apart really easily. Putting a rock into solution is literally pulling the agent out of that rock and moving it somewhere else. We're dissolving the mineral of that rock. What we've got in this picture here is some limestone, and with limestone is easily dissolved by water, creating these pitted areas that you see here. This happens to be in Scotland, a nice easy area to see that the parts of the rock which were most susceptible to solution removal is along the bedding planes or the joints. So you can see the regularity of the joints in here. They're at right angles to each other, very geometric. We've got lots and lots of solution landforms in places like Kentucky and Tennessee here in the United States.